All right, guys, I hope you guys can hear me well. So I don't want to waste all that time and then realize nothing was recording. This is a catch-up video for calculus for some of the students who are in the work experience and were away for this week. And I just wanted to go through some examples. Now, first thing first, most of the things that you guys missed out on are techniques of calculus, more specifically, differentiation. The booklet is called Rules of Differentiation, but they're the fancy ones, and obviously we do call them rules, but it's essentially how do we differentiate more complex questions, more complex functions. As an example, if I had as an example y equals to x plus 1 squared, and I wish to find y dash, you would say, oh, look, I think I would just expand this out, and then I'd say, oh, 2x plus 2. And then now that's it. That's all done. The problem is, what if we have more complex questions? What if we have y equals to 3x cubed plus 2x to the power of 4? I'm not going to spend my time expanding any of this because this is too much time, too much effort. Okay? What we start to realize is that this actually can be simplified into nicer terms. What is the thing that is annoying me right now? What is the thing that is making it more complicated? It's the fact that this function that's inside a bracket is being powered by 4. What I'm going to do is I'm going to just say, you know what, screw you. I'm going to write this and say u is equal to 3x cubed plus 2x. This is making a fake substitution. Well, what's the point of this? Well, what it does is that then y becomes u to the power of 4. So what difference does it make? I don't know. Just gonna put myself over here so you guys can see me a bit, see the thing a bit better. Well, what is my end goal? I want to eventually reach dy dx. But remember, dy dx is essentially a fraction. That's how the derivative works. It's the difference between the y divided by the difference of the x's. So it's going to be able to use the same rules that we use for fractions. What do we know about fractions? What do we like about fractions? They cancel out very easily. If I were to just make up this expression for no reason, we notice that these would cancel out, and then we would still get the answer. But what is good is that from u, I am able to make du dx, right? Because u can be differentiated in terms of x. What else do we know? Y can be differentiated in terms of u. So what does that mean? This, we can get dy du. Do we notice what we can make with this expression? Du dx would be 9x squared plus 2, and then dy on du would be 4u cubed. This means I can replace whatever I have here with 4u cubed times bracket 9x squared plus 2. So what? What is u? 4 bracket 3x cubed plus 2x bracket, what was outside already. As a matter of fact, this is it. That's my derivative. I did not have to take this complex looking function. I did not have to expand it. I didn't have to expand it. I just had to use this weird identity. This, you will not actually have to use this particular skill in exams because I'm going to teach you just a simplified rule to memorize. This is not obviously the most optimal way to go about it because in advanced, everything can be reduced into just simply memorizing how to differentiate, and that is all we need to do. What is that rule that we just want to memorize? If y equals to f of g of x, y dash then equals f dash of g of x times by g dash of x. This is the rule that you want to know. And this is called chain rule. Because it has chain of functions. Like we just gotta keep chaining them up. We do this and then we do that. And it just times and multiplies. So example. What's an example? Let's say if y equals to 2x minus x squared to the power of 5. All I need to worry about is what is the inside function and then what is the unknown one. Okay, so y dash would be 5 and then now it gets differentiated 2x minus x squared to the power of 4. So all we just did was we just differentiated the power as we normally would with any of the functions that is normal, and it's just all in a straight line. But we also multiply by the derivative of the inside, which in our case is 2 minus 2x. So we just multiply by 2 minus 2x, and I'm just going to highlight it in yellow so you know this is the same thing. Okay? And that's it. And we just, like, if you can simplify it, then you go ahead. I factor out the 2 and then with the 5, and I get the 1 minus x combined, and then I'm going to put the ugliest one furthest at the back. Oops. And that's it. That's all we need to do. Okay? Harder example. If I have something like this, y equals to 1 over x plus 1. What do we remember? We can't really differentiate fractions as they are. Not for now. I'll teach you guys later how to do this. But right now, the best way we had to deal with this was change this into an index form, so power of negative 1. We can do this to a function too, a function with multiple terms, not squared, negative 1. Now, what am I going to do? Oh, y dash is going to be negative 1, negative 2, x plus 1. And then what is the derivative of the inside? Times by 1. So negative 1, x plus 1 to the power of negative 2, in which case we can simplify to negative 1 over x plus 1 squared. Ideally, if you wish to be really aesthetic with your working out and your reader to be happy when they're reading it, you would prefer to leave it as like a positive index, whole number index, or into surds when there's fractional indices. But you shouldn't really lose marks for this point anyway. Like you've done what you needed to do. If you care about perfection, then you do this. But who really cares, right? Okay. Another example. Just making a new page every time I do it. 2.0. Let's see. What else is there? What if I give you this? Y equals to square root of 3x squared minus 2. Get rid of this actually, because I don't have to worry about this thing. Now, what do I know? This is complicated, but what do I know about square roots? In index form, this can be written as 3x squared minus 2 to the power of half. Same rule now. Stupid half power, come out here, and then it gets minus by 1. And then you keep the 3x squared minus 2 on the inside, and then you multiply by the derivative of the inside. Yeah? So now you get 6x and nothing, because it's just a constant. So now you get 3x squared minus 2, power of negative half. And again, if you don't really care about perfectionism, you can just leave it, but you can do this. Because it's a negative power, it goes down, and then because it's a half, it gets a square root. All good? That's it for chain rule. And then have a go at the booklet questions and see how you go.